Hello, this is Mr. Taylor with the Young Engineers of Today. This is a recap of our webinar on Monday, the 5th of May. Basically, what we did here was we reviewed liquid propellant launches and we tried this out, building some test rockets. It's important that you try this out, experimenting using your throttle controls with the left shift and left control buttons. Then we reviewed orbiting, remembering that the closer you are to the planet, it's going to speed up your velocity as compared to being further away because of gravitational pull. All right, and we reviewed this little image here of that taking place. Okay. And we talked about changing trajectory, which was a review from the previous week, and how your trajectory is important with retro burn and retrograde, which are used to slow down, versus prograde and pro burn, which is to speed up. Okay. All right. Then we went into building a orbiting rocket we built on top of the basic liquid propulsion rocket and added multiple stages below. If you can't find the FLT400, LVT300, find the nearest thing to it, and you'll build 3 fuel tanks and another engine on the bottom. And eventually you actually, if you notice, you have 2 decouplers here. Then we talked about fins with aerodynamic tab. It's important that you use this because doing it on your own is very hard to put these fins on. And we talked about symmetric flaps. If you click twice, it puts 3 flaps. You click 3 times, it puts 4. And then these are a large quantity of tips. Students pointed out during the webinar that tip number 3 in your bullets is very important. It's almost as well as almost as important as tip 5, which was also recommended that you try waiting to closer to 1,400 meters. A lot of people found success with that instead of the 10,000 meters. All right. And then what your objective here is to launch into outer space, do a little bit of orbiting, and be able to come back into your planet and land. Practice doing this. It's challenging, but do the best you can. The important part is conserving fuel. All right, using that press T feature will help keep your automatic system in line, so you don't waste fuel with the WASD keys. All right, we're going to switch gears here. All right. Principles of rocketry. For Wednesday, you're going to need a pop bottle, soda pop bottle, 2 liter, a liter, or 20 ounce, and a cork that will fit that lit bottom, and some tape and some cardboard. So we're going to be making one of these devices. All right. Please go to this link and explore it. It is tied to rockets through NASA. Okay. And this is an example of what it'll end up looking like. And we talked about what is a rocket. As you can see here, chamber enclosed, closing a gas under pressure, such as a balloon. We went over Newton's 3 laws. Object rests will remain at rest. Object in motion will remain in motion in a straight line unless acted upon by an unbalanced force. Number 2, force equals mass times acceleration. And number 3, every action has an equal and opposite reaction. Here's an example of Newton's first law. Here is explaining it in depth for Newton's second law on rockets. You can read these both. And then here is the action-reaction taking place, as you can see here. Okay. Next class, we'll talk about design considerations. Once again, you need a 2 liter 1 liter, 20-ounce bottle, and a cork that will fit that, some construction board, scissors, and tape. All right, thank you. And this is Mr. Taylor with Young